Mars, the red planet, an inhospitable wasteland, but the next step in man's exploration of the universe. As our nearest planetary neighbour, Mars has been a target of space exploration for decades, yet no human has ever set foot there, and it is a very different place to anywhere on Earth. Mars is located 1.5 AU from the Sun and has half the diameter of Earth, measuring around 6,800 kilometres across. As it is further from the Sun than Earth, a Martian year is 687 Earth days, whilst each Martian day lasts 40 minutes longer than that of Earth. Mars has an average surface temperature of minus 63 degrees C, though values between minus 140 and 30 degrees C are typical. The gravity is 62.5% weaker than on Earth, and the atmosphere, 96% of which is carbon dioxide, is 100 times less dense. To survive in such an environment will require collaboration of the sciences to solve all the problems potential colonists may face. In the rest of this presentation, Resources for Mars, we hope to address just some of these problems and potential solutions.
Water is an essential element for organisms. It is used as a solvent during transportation of nutrients and excretory products, as well as during the secretion of substances. The majority of essential metabolic reactions also occur in water solutions. Additionally, it is a raw material or a product of many reactions in the body, such as hydrolysis, the breakdown of large polymers into monomers by the addition of water. Finally, water is used for temperature regulation within the body to prevent issues with other processes such as the digestion of food.
Another critical chemical for life is oxygen, which plays many important roles, foremost that of oxidizing our food in the process of cellular respiration, which takes place in the organelle mitochondria. This releases energy as well as carbon dioxide and water. Without sufficient oxygen, anaerobic respiration takes place where lactic acid is produced instead of carbon dioxide, and less energy is released. Anaerobic respiration cannot be maintained for long periods of time due to acid buildup in the muscles.
We know the resources we need, but we still need a way to produce these resources on Mars. One possible way may be to use plants, as these convert carbon dioxide, abundant in Mars's atmosphere, to oxygen.
Another method is the Sabatier process, in which carbon dioxide and hydrogen are combined to make methane and water, with a nickel or ruthenium catalyst. From here, the water could be broken down into hydrogen to reuse and oxygen. Alternatively, if hydrogen were to become an issue, Mars's CO2-rich atmosphere could be directly broken down into oxygen and carbon monoxide, though this would require a ceramic catalyst.
So, where will we obtain these resources? One answer lies on the surface of Mars. Martian soil called regolith contains a multitude of compounds useful for a developing colony, including water with concentrations up to 6% at the poles, as well as iron and aluminium oxides. The soil can also be used as a construction material utilising a sulphur cement rather than a limestone cement to create buildings as strong as most on Earth. Such buildings also insulate the air inside, reducing the energy requirements of the colony, and additionally provide protection from the frequent harsh dust storms on Mars. Whilst the soil contains a lot of compounds, there has been no evidence to suggest the presence of nitrogen, and the atmosphere contains only around 1.9%. Therefore, as it is required to grow plants, nitrogen will have to be brought from Earth to use in fertilisers.
Another key resource to any Mars mission will be electricity. This will most likely be generated using solar panels, which generate electricity using something called the photovoltaic effect. In this process, a small amount of energy is absorbed from incident light by an electron in the solar panel. As a result, the electron moves from a lower energy orbit around its nucleus, called the valence band, to a higher energy one, called the conduction band, where it is free to move, giving electrical current. Solar panels, however, are large and difficult to transport to Mars and present problems such as what to do at night and how to deal with dust buildup. A more practical method, therefore, especially in the early days of such a mission, may be the use of RTGs, which have been used in much of our exploration of Mars so far. These use a nuclear fuel source to heat a block made of two different metals, and the difference in heat across these two creates an electrical current.